I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are going to discuss the concepts about planes in this particular video with a very bright student, Akshit. He is scoring 100% marks in his grade 12 exams. In case you want to learn from me, you can always join my classes by sending an email on the address given. Let us now clear our concepts and enjoy the journey of success. Hi Akshit, how are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So today, what do you want to learn?
Sir, today I was hoping we can go over the vector and parametric and Cartesian equations of a plane.
Okay, so you understand vectors as far as lines are concerned, and now you want to understand equation of planes in vectors, right?
Right.
Okay, so let me just share with you a whiteboard and we'll talk about it.
Yes, sir.
So we are talking now about planes. The major topic is vectors, of course. Just as in lines, we have different types of equations, right?
Right.
Taylor equation, vector equation, parametric equation. Similar,
Right.
in planes also, we have different kinds of equations. So we have a vector equation.
Yeah.
We do have parametric equation. Cartesian equation. Now, how to define a plane? Can you tell me how can I define a plane? For example, a line is defined by 2 points, correct?
Yes, sir.
As far as line is concerned, we need 2 distinct points.
Right. So for a plane, it would be 3 distinct points, right?
Correct. For a plane, we need 3 distinct points. For lines, you can also define a line if you know 1 point and radian, right?
Right.
1 point and slope, you can define. In planes, what are the other ways in defining a plane?
Sir, we can define it using the x, y, and z axis too, right?
With x, y, z axis, we could define a point also, a line also, a plane also, right? But
Right.
to distinctly define a particular plane, what do we need? So there are a couple of things which we need, right? We could have option of having, let's say this is a plane. Think paper is your plane to work with.
Right.
I'm saying 3 distinct points means these points, right? So if I have 3 points, then all the 3 can be contained only in one plane. You get the idea?
Yeah.
So if I change this plane in any direction, then one of these points will go out of the plane.
Right.
So that's what we mean. And we could have defined a plane by 2 lines also. So if I have 2 lines, let's say these are the 2 lines, they also define a plane.
Right.
So 2 lines, you could consider, let's say 3 points. You could see 3 points also give you 2 lines, right?
Right.
So 2 point lines also give you a plane. Well, 2 parallel lines could also give you a plane. We'll see how to use them. Right? Any 2 points. Because if you have 2 parallel lines, when we could actually have 1 point on this line, 1 point on that line, and you see that? So we
Right.
get another
Yeah.
direction, and that is effectively we could get 2 lines on this particular plane. You get the idea. So to define
Yes, sir.
one plane, we could have 3 points, 2 lines, or 2 parallel lines, correct? Or we
Correct.
could also have a point and a line.
Right.
So that is to say, let's say we have a line here and we have some point. So that will also define a
Yeah.
plane. So we have these four options to define a plane uniquely. Is it clear to you?
Yes, sir.
Because using any of these options, a line can be defined by 2 points. You see that. So ultimately, we
Yeah.
have 3 points. Okay?
Right.
So that is how we could say we can define a particular plane. Now let's get back to equations of the plane. Let me clear the screen. This concept I hope is clear to you.
Yes, sir.
Now let's say that we know one particular point, right? So let's say this point P is given to us, and we also know a line. So from point, let's say this is a line also known to us, right? In
Right.
that case, how do we define a plane? So we could, because a line is known to us, we'll have two lines on the plane itself. So that will give you two different directions, right?
Right.
Or we could use one point and the other line, right? So that gives you the combination of directions. So that helps you to define a particular plane. So let us now derive an expression uh, to form an equation. So we'll now look into first vector equation.
Yeah. Sir, quick question. So even a triangle can be considered a plane, right? With
Yes.
the 3 points?
Yes.
Right.
So vector equation of plane. So when I'm saying vector equation of plane, what I will do here is plane is in R3, right? So
Right.
let's consider the corner of the room.
Yeah.
When we look at a plane, we're looking at a piece of paper. It could be placed anywhere, right? That is our
Right.
plane, right? So that is what we're looking for. So to define a plane, let's say that is our paper, right? So let's say this is our paper. We try to draw parallel lines to give you an idea of how this paper is like floating somewhere, right?
Right.
Now, this plane could be defined, as I said, in many different ways. So we could have a point and a line, right?
Right.
Or we could have two lines. So let's consider, let's say, two lines. This is one line, and let's say that is the other line. Is it okay?
Yes, sir.
These two lines, let's say they have a common point here. Then you can see that any point on this particular plane can be found by having linear combination of these two lines.
Yes. Yeah.
Correct? Any point.
Correct.
So for example, if I could draw a parallel line here, right, and a parallel line with this here, that point is taken care of. You get the idea.
Yeah.
So that is like a scalar sum. Do you see that?
Yes, sir.
So if we do scalar multiple of this and find the sum, right, linear combination. So with the help of linear combination, in the plane, right? So
Right.
what we're trying to say here is that let us say this point is known to us. Let's call this point as R0 or anything, right?
Yeah.
And the combination we are talking about is, let's say this is U times A vector, right? And this is V times vector B. These are the two vectors given to us, the line represented by these vectors, right? So the linear combination will be from R0, we'll add this, right? And then this, correct? So we get this,
Right.
you'll get the idea. So,
Yes, sir.
so the plane, which normally will be denoted by the letter pi. So when we write pi, we mean this is a plane, right? So we define a plane pi as R0 plus some multiple of A plus some multiple of B. So that's the combination.
Right.
with which we are defining a plane. So basically, we are looking into the direction. Do you understand?
Yes, sir.
The direction of these 2 points, and then we are looking at a point, right? So in a way, I could say x0, y0, z0. That is the initial point, right?
Yes,
Plus
sir. That makes up R0, right?
yeah, that makes up r0 s times, let's say, a1, a2, a3, right? That makes
A3,
the second,
right.
plus t times
B1, B2, B3.
I mean, not b2, b3. Where s and t are parameters. S and t belongs to real numbers. Right?
Yes, sir.
So what is happening here is that we have two parameters. A line is single dimension. You see, that is 2D.
Yeah.
A plane is two-dimensional. Two-dimensional means two parameters will be required to define a structure which is two-dimensional. So plane is
Right.
two-dimensional. S and T are two parameters which will help us define a plane. You get the idea?
Yes, sir.
Correct? So that is one way of doing it. Now, let's take up an example. Let's consider any points. Let's say point A is, let's say, 301, and let's say B is -215. Just randomly writing any points, right? Let's say this is
Right.
-112. So if I am given 3 points uniquely, these 3 points will define a plane. So can you write down the equation of a plane?
Yes, sir.
How will you do it?
So, sir, the vector equation we said would be R0, which is just a point, right?
Yeah,
Plus VA plus VB.
yeah, you can take any point.
Yeah, so we'll take A as that point, right?
Okay.
And then can we just set, yeah, so AB and AC, right?
Yeah, AB and AC. So you can say plus S times AB, right? Plus E times
AC.
AC, right?
Right.
You get your equation. Do you see that?
Yes, sir.
That's a plane one. So you can write this plane equation as you said, 301, correct? Plus
Correct.
this times. Now,
vector AB.
AB -2 -3 means
-5. 1 and 4.
And 4, correct?
Correct.
Plus T, -1, -3, -4.
-4.
1
and 1.
You get the idea. You get a plane.
Yeah.
So that is how you can get a plane. Now, as we did in lines, we could write now parametric equation of a plane, right?
Yeah.
So let's get into that part now. So initially, we said what? A plane phi could be defined as, let's say, x0, y0, z0. That's our initial point, right?
Right.
Plus t times a1, a2, a3, okay?
Yeah.
S times b1,
B3.
So parametric equation can be written as x is equals to x0 plus a1t, right?
Right. Plus B1s.
B1x. And y equals to y0 plus a2t plus b2s,
B2s.
Right? And z,
Yeah.
any point can be written as 0, z0, right? Plus
Right.
a3t plus b3s. Is that clear?
Yeah.
And here, of course, we know s and t belongs to real numbers.
Real numbers.
So that is how you could write a parametric equation of a plane.
Yes, sir.
Now, another very important concept is that we are now moving on to the Cartesian equation of the plane. So, okay, so I'll just first introduce you to all the equations, then we'll work on them. This is parametric.
Right.
Perfect. Now let's look into, so how do you distinguish between equation of a line and a plane? We've got two parameters. So it is a plane.
2 parameters.
So in parametric equation of a line, there was only one parameter, right?
One parameter, right.
So that is easy way of distinguishing. Because the names are similar. Sometimes we get confused about it. Correct?
Yeah, yeah.
We can now
So that's what.
discuss some questions in your book.
You can see, right, sir?
Yeah. So this is plane. So we talked about
Yeah.
different conditions of defining a plane, right? Move on.
Right.
Correct. So those are the different equations, right?
Right.
Let's read the summary.
Yeah. In R3, if R0 vector is equal to x0, y0, z0, is determined by a point on a plane, and A vector is equal to A1, A2, A3, and B vector is equal to B1, B2, B3, and are direction vectors, then the vector equation of the plane is R equals R0 plus SA plus TB, where S and T are elements of real numbers, or equivalently, X, Y, and Z is equal to X0, Y0, Z0 plus S times A1, A2, A3 plus T times B1, B2, B3. The parametric form of the equation of the plane is X equals to A0 plus SA1 plus TB1, and Y is equal to Y0 plus SA2 plus TB2, and Z is equal to Z0 plus SA3 plus TB3, where S and T are elements of real numbers, and there is no symmetric equation of the plane. Correct.
So let's take few questions. Can you answer any one of them? Pick any one of them.
Yes, sir. So the first one says state which of the following equations define lines and which define planes. So the ones with just one scalar would just be lines, and then the others would be planes.
You're right. So as soon as you see S and T, you know that is a plane, and as you see only one, that is a line. So that is a clear distinction, right? Next question.
A plane has vector equation this, such that S and T are elements of real numbers. Express the first direction vector with only integers.
Means you can take common denominator out here, right?
Right.
So multiply everything by 12, correct? So you get S.
Right.
When you multiply by 12, you get 4. And 12 times is minus 24.
Minus 24.
And that gives
and 9.
9, correct. Continue.
Reduce the second direction vector. So then just take 6 common, right?
Yeah. So normally you write them in the simplest form and you do not write fractions. This is what we're trying to say here. Continue.
Right. Write a new equation for the plane using the calculations from parts A and B. Oh, so then we just put it together. Yeah. Next. A plane has x equals 2m, y equals minus 3m plus 5m, z equals minus 1 minus 3m, minus 2n, where m and n are elements of real numbers, as its parametric equations. By inspection, identify the coordinates of a point that is on this plane. Can you tell me? Yes, sir. So I think if we assign some values for m and n, then we can get points, right? No. M and n are parameters. So try to understand this part. Okay, let me do it here. Yeah. To show you how it works. Okay. So x is equal to 2m. Think m and n are parameters, right? So 2m, and then we are writing y equals to minus 3m, and then plus 5m, Is okay? And z is equal to minus 1, minus 3m, minus 2n. Do you see how I wrote? Oh, okay. Yeah. So this is like, so the verticals are the points. 0. Do you see that? Yeah. So the coordinates of the points are 0, 0, minus 1. Do you see that? Yeah. And parameters are m. So for m, we'll have plus m times, instead of s and t, 2 minus 3 minus 3, right? Do you see that? Yes, sir. And those two verticals are our direction vectors, right? These are the direction vectors. 0 and 5 and minus 2. The idea. So you have to write it in this fashion. Then absolutely clear it is, no confusion. Yeah. Okay, clear. Next question, please. Move on. Yes, sir. What are the direction vectors for this plane? I think we just answered. We did all this. Yeah. Continue. Skip. Go to question. 4, sir? Yeah. Yeah, a plane passes through the points P minus 231, Q minus 232, and R101. Using PQ and PR as direction vectors, write a vector equation for this plane. Easy, okay. Right? Yeah. And using QR and one other direction vector, write a second vector equation. Yeah. Correct. Explain why the equation R equals to minus 1, 0, minus 1 plus S 2, 3, minus 4 plus T 4, 6, minus 8 does not represent the equation of a plane. what does this equation represent?
Tell me.
Right, sir. So it has two parameters, right?
No, these are same directions.
Right.
2,
So
3
if I
minus
take
4,
2
2, 3
common,
minus 4. Yeah. So
yeah,
it is the same line. So it is not 2. It is one line. So it's
yeah,
basically equation of a line, not a plane. So just don't go with the S and T, right? Sometimes it could be
right.
like this. You get the idea.
Yes, sir. So always look for factoring, right?
Correct. This is as good
Yeah.
as just writing S 2, 3 minus 4, right?
Right.
Because S plus T is also a real number. You get the
Yeah.
idea. So
Yeah.
basically you have one parameter.
One
Right.
parameter.
Next. Good question.
Determine vector equations and corresponding parametric equations of each plane. The
Yeah.
plane with direction vectors A is equal to 4, 1, 0, B is equal to 3, 4, minus 1, passing through the point A minus 1, 2, 7.
Correct. You can do all that, right?
Yes, sir.
Continue. Further, continue. So you can do all that. Skip. Yeah, continue.
Yes, sir.
13 question number.
Determine a vector equation for the plane containing the points 0, 0, 0, minus
Easy.
1, 2, 5. Yeah, 3, minus 1, 7.
Part C, question 16. Let's read that.
Suppose that the lines L1 and L2 are defined by the equations R is equal to OP0 plus SA and R is equal to OP0 plus TB, respectively, where S and T are elements of real numbers and A and B are non-collinear vectors.
Correct.
Prove that the plane defined by the equation contains both of these lines.
Correct. So, because any point on any one of the lines will be there in the plane. You get the idea.
Yes, sir.
So that is why you can prove that this is equal to this.
So, sir, this proving has to be done like verbally, right?
Okay, so you can see as far as the two lines are concerned, a plane is defined by a point and two lines, right?
Right.
Lines, when we say, we are talking about two directions.
Right.
So OP is your common point.
Right.
So from OP, you're drawing one line like this. From OP, you're drawing the other line like this. Is that clear to you?
Yeah.
Correct? So prove that
Correct.
the plane defined by R, which is this, which is, you can now say this is a plane defined by R, correct?
Yeah.
Because it contains both these lines. So this plane contains both these lines because the equation of the plane will be this. Is that okay?
Oh, okay, so this is one of the cases, right, sir?
Yeah.
That we discussed? Yeah.
Okay, so we can move on to 8.5 now.
Yes, sir, the Cartesian equation.
Correct. So as they have shown in the diagram, let's see the diagram once again. Very interesting. So
yeah,
we are talking about a perpendicular going through it, right? You see this plane and they made them 90 degrees.
Right.
Right. So we're talking about a normal vector and a point. So if there's a normal vector, if I have a point somewhere here, it will define a plane at this position. Do you see that?
Yes, sir.
Different
right.
Plane. So all those planes with the same normal will be parallel.
Right.
But if we know a plane and a fixed distance, then it is unique.
Right.
So you can actually define a plane by just a normal and a point on the plane.
Yeah.
Right? So that is how we have defined this. Now move on. So how do you get normal? So that's normal means, okay. Now look, so normal into another line. So this PP0 is any point on the plane, right? So you see, can you please read this?
Yes, sir. To derive the equation of this plane, we need 2 points on the plane. P0, its coordinates given, and the general point P, different from P0. The vector P0P is equal to x minus x0, y minus y0, and z minus z0. Represents any vector on the plane. If vector n is equal to on, which has coordinates a, b, c, and is a known normal to the plane, then the relationship n dot p0p is equal to 0. Oh, because they're perpendicular, right, sir?
Yeah, let me make it like this. So it becomes easy, right? Let's say this is the normal, right? This is the normal, correct?
Correct.
And we have any line on the plane, any line on the plane. So this will make 90 degrees with it. Think about the table. And if your pen is standing on the table, it is normal to any line on the plane, correct?
Right.
So By defining 2 points, we are defining a line, direction, and the dot product between them has to be 0. Is that
0. Yes,
so?
sir.
You take initial value, let's say x 0, y 0, z 0, and this is some value, general value, x, y, z.
Yeah.
Wherever we write x, y, z, it means general. It could be anywhere, right?
Right.
Any line. So this will be a normal. You see that?
Right, sir. And the dot product is 0, right?
And the dot product is 0. So as soon as you do dot product and expand, you get the term ax, by, c, z, and the other terms are constant.
Constant.
A at 0,
right.
A is constant because normal is given to you. Normal is ABC, correct?
Right.
And so you can write all of them as a constant D. So this
Right.
is written as a constant D, and that is
D.
how you get your equation. And that should be equal to 0 because the dot product is 0. Is it clear?
Is 0. Yes, sir. Makes sense.
So that is how you do scalar or Cartesian equation of a plane. Yeah. Next.
Yeah.
So you have understood this concept, right? Let's take
Yes,
up
sir.
questions. So if two planes are parallel, they have the same normal, correct?
They have the same normal, right?
Angle between the two planes will be same as angle between the two normals.
Right.
And normal of a plane is ABC, which is the coefficient of XYZ.
Right.
Now read the key summary.
Yes, sir. The Cartesian equation of a plane in R3 is ax plus by plus cz plus d is equal to 0, where vector n has coordinates a, b, c, and is a normal to the plane, and vector n is equal to a cross b dot a and b are any two non-collinear direction vectors of the plane.
Yeah, normal you get by cross product, right? So if there are two lines, then their direct
Okay.
yeah, cross product is
Yeah.
there, right? Yeah.
Yes, sir.
Yeah, that should be comma, not dot, right?
Right. Sir, I have a quick question. So about I get the perpendicular planes, right?
Yeah.
But going back to the parallel planes,
Yeah.
so what if we were asked to find the angle between? We would just look at the normal.
Angle is 0.
Angle is 0, right?
Yeah.
Okay. Yeah.
Because if they are normals, if you do, the normal angle is 0, right?
Right.
Angle between the planes is same as angle between the normals. So
Right.
they have shown the other plane perpendicular, so their normals are at right angle. You see that?
90 degrees, yeah.
And plane angles are also 90 degrees.
Yes, sir, got it. Okay, so the first question says a plane is defined by the equation x minus 7y minus 18z is equal to 0. What is a normal vector to this plane? So it would just be the coefficients, right?
1 minus 7 minus 18. And this plane actually passes through origin. Because see, D is 0.
Right.
So when I plug in 0, 0, 0, it satisfies the equation. So now 0 is in the plane. You get the idea. The plane passes through 0. Is it okay?
Yes, sir. So if D is 0, it always passes through the origin, right?
Correct.
Yeah. Write the coordinates of 3 points on this plane.
Plug in x, y, z, any point. Find the third point.
Yeah.
Plug in 1, 1 for x and y and find z. Like this. You can plug 0, 0 for 2 and then find the third point.
Right. So you can isolate for x in this case, right? It'd be easy.
Yeah.
Yes, sir. So these are all similar questions.
Correct.
A plane is determined by the normal disk and passes through the origin. Write the Cartesian equation, where the normal is in reduced form.
Right. Only thing is you'll factor 5, right?
15.
15 rather, and then you can write down. Correct.
Yeah. Okay. A plane is determined by a normal n and contains the point minus 3, 3, and 5. Determine a Cartesian equation for this plane using the two methods shown in example 1.
Okay. So how will you do it?
Right. So if it's determined by this normal, then the A, B, and C coordinates would be this.
Correct.
And it contains the point this. So to find D, we can plug these in and then solve for D.
Correct. So basically you're saying AX plus BY plus CZ plus D equals to 0. You know ABC, which is 175. So your equation is X plus 7Y plus 5Z plus D equal to 0. Now you know the point. Plug in this point for X, Y, Z. So you get minus 3 plus 7 times 3 plus 5 times 5 plus D
Plus D.
equals to 0. So only unknown is D. Calculate. Here.
Right.
This is one method, correct? What is
Correct.
the other method to find this equation? So other method will be that let there be a general point x, y, z, right?
Right.
Then we have to do the dot product between 175
Okay.
and x minus this, which becomes plus 3.
X plus
5
3.
minus 3, you see that? And z
Yeah.
minus 5. Is it okay?
Yes, sir.
Equals to 0. So when you do that, 1 times this will be x plus 3, right?
Right.
Plus 7 times y minus 21 plus 5 times z. And we have this, I wrote what? Minus 5, right? So 5 times 5.
Yes, sir. Z minus 5.
Yeah. Z minus 5. Z minus 5, right?
Yeah. So it'd be 5z minus 25.
Minus 25, right? Minus 25 equals to 0. So we know x, y, z components, right? So
Right.
x plus 7y plus 5z, correct?
Correct.
Combine all the constants, 3 minus 21 and minus 25. Add them up, right? So when you take away 3 from this, you get 18 and add to 21. Or you can say 46 minus 3. So 43. Is it okay? Minus.
Yes, sir.
Is that clear to you? So likewise,
yes, sir.
You can easily use both these methods and find the answer. Correct?
Correct.
Okay. Continue.
The three non-collinear points P, Q, R lie on a plane. Using P, Q, and Q, R as direction vectors in the point, determine the Cartesian equation. Right. Okay, yeah. This is similar.
Okay, question number 9 looks slightly different. Have a look at it.
Yeah. Determine unit vectors that are normal to each of the following planes.
So you have to now find unit vectors which are normal to these planes. How will you do that? Because what we from the plane, we only know the normal vector. Is that okay?
Right.
Now we need to find unit vectors that are normal to each plane. So let's consider this plane, right? So
right.
How will you find two vectors on the plane? Tell me.
So to find two vectors on the plane, right? Then we can find we can use 2 points to find the vectors.
3 points.
Yeah, 3 points, right.
Yeah. So just point 3 points. So one, you put x and y 0, 0, right?
Right.
Find z. So you could have 0 for x, 0 for y. Then in that case, z is minus 1. Do you see that?
Yeah. And that's our first point.
Yeah, that's our first point. Then put 0 for y and z and calculate x. You get the idea.
Right. Yeah.
If I put 0 for y and z, I get 2x equals to 1 or x equals to half, right?
Yes, sir.
Is that clear to you?
Yes, sir. Clear.
I could put now third point I need to find. So I could put 0, 1 and 1, for example, and find z. So
yeah.
Right. So if I write, let's say 1, and if I write, let me write 0 here. It is easy, right? 1, 0.
Yeah.
1 is there. 1 minus 1 is 0. So
right.
is also equals to 0. You see that?
Yeah.
So you got 3 easy points to work with. Now you find 2 directions. These are unit. To find the unit vector, you have to divide by the magnitude. Remember?
Magnitude.
So now, if you say this point is A, this is B, and this is C, which are very simple points for us. So what is AB? AB will be
1, 0, and 1.
Yeah, you can do 1 minus this, right? 1, 0, and 1, correct?
Correct.
And the unit vector will be, you have to divide this by the magnitude, which is 1 square plus 1 square, which is square root 2.
Square root 2.
That becomes the unit vector. So this becomes the unit vector AB. Similar, you can find a vector between these two, correct? You can also multiply the whole thing by 2, because this is the direction.
Yeah.
Just to make it simple. But
that sir, I can.
Yeah.
Sir, I can also find the direction. Sorry, the vector between AC, right?
Oh yeah.
Anything. Yeah.
Anything. Yeah, between these two. Yeah.
Yeah.
So your vector will be half, 0, and 1. Correct.
1. Right.
So that could be one vector, right? So to make it simpler, you can make this as a 102. You get the idea?
Yes, sir.
So that to avoid fractions. And then divide by the magnitude. 1 square plus 2 square is 5. So square root
Square root 5.
You get the unit vector. You get the idea, right?
Yes, sir. I got it.
That is how. So when you're working with Cartesian equation and you have to find directions, find 3 points on that plane.
Right.
Let's look into question 13.
Yeah.
Read.
Determine the angle between the planes x plus 2y minus 3z minus 4 is equal to 0 and x plus 2y minus 1 is equal to 0.
Tell me how will you do it?
Right. So, sir, in order to determine the angle, right? I saw before that they were using the cosine of theta.
Dot product, right?
The dot product.
B is
right.
AB cos theta.
Right. So we would have to form our vectors.
Normal. So n1 dot n2, right?
Right.
Is equals to magnitude of n1 times magnitude of n2 times cos theta, correct?
Cos theta. Right.
So cos theta is equal to dot product of n1 and n2
divided by their magnitudes, multiplied.
Divided by their magnitudes, right?
Right.
Find theta. That is the angle between the two planes. Is that clear to you?
Yes, sir. And in this case, sir, our n1 and n2 would be just the coefficients of the normal, right?
1, 2, yeah, 1, 2, and minus 3. And
right.
here it is 1, 2, and 0.
Yeah. Right.
Easy.
Yeah.
So that is how you're doing. Okay, read question 14.
Yeah. What is the value of k that makes the planes 4x plus ky minus 2z plus 1 equals to 0 and 2x plus 4y minus z plus 4 equals to 0 parallel?
Correct.
Right.
N1 is scalar multiple of N2, right?
Right.
A times N2. So you can see it is twice, right? 2 times. So K has to be 2 times 4, 8.
4, 8. Yeah.
Right.
Yes, sir.
So clear? Let's go. Almost the end of the exercise, right? Akshit, can you please read question number 17?
Yes, sir. Determine the equation of the plane that lies between the points minus 1, 2, and 4, and 3, 1, minus 4, and is equidistant from them.
How will you do this?
Right. So, sir, if it's a plane that lies between 2 points, right, then once again, in order to form it, then we need one more point, right?
Yes.
To form the plane. So if we find that, and then are we allowed to use the distance formula in this case?
No need.
No need.
Okay, we'll take our whiteboard. Let me just show you the solution. Right. So you can start.
I'll just note down the points.
Yeah, note down the points. Okay.
Yeah.
And you can stop sharing. I'll share on the whiteboard. Explain you, right? So tell me what are the points?
Yes, sir. The points were minus 1, 2, and 4.
Other points?
And 3, 1, minus 4.
So these are the 2 points given to us.
Yeah.
Find the direction between them. Let's say these points are P and Q, right?
Yeah.
So PQ is what?
So it would be minus 4, 1, and 8.
Minus 4, 1, and PQ. This is your normal. Do you see that? Because we want to make a plane right in the center. Do you see that?
Right.
So, and the point is midway.
Yeah.
Normal is given to us. Point is the average of these two. Add them, divide by 2. Let's call this point. Add them. 3 minus 1 is 2. Divide by 2. Correct? 1 plus 2 is 3. 1.5. Is it okay?
Yes, sir.
And this is 4, 4, 0, right?
0.
That's
okay, that's it.
Correct. Now, you have the equation, which is minus 4x plus 1y plus 8z plus d equals to 0. Plug in the 1 minus. So when you put 1 here, you get minus 4.
Minus 4.
Plus 1.5 plus 0 plus d equals to 0. Find d. So d equals to minus 4 minus this is minus 4 minus
2.5.
4 minus 1.5. This is
2.5.
So that's the equation. Do you get the idea?
Oh, wow.
So this plane will be midway between the 2 points, correct?
Correct.
Very interesting question, and it comes in
Yeah.
depth. So we are ending with this very brilliant question, which happens to be the last in your book also.
Yeah.
So that gives you a good concept, right?
Yes, sir. So in this case, sir, we found PQ on purpose, right? Because it draws through the center of the
Normal.
plane.
Yeah.
Normal
PQ
to the
because we
plane.
want normal, right?
Right.
So between this, right in the center, we are going for a plane. So that this is your
Right.
normal. You get the
Yeah.
idea?
Yes, sir.
That's the one. Okay. So we'll stop sharing, and I'd like you to summarize today's learnings. Can you please summarize today's learnings?
Yes, sir. So today we touched upon planes, and it was a good review for my test that's upcoming on Monday. And so I think it's really solidified on how to attack these plane problems, right? Because they're a bit different than lines because they have extra
Yeah.
parameters and they require a little bit more extra attention when it comes to solving them.
Yeah.
So I think I'll be able to accurately do the problems now because I have the idea on what to do, right?
Sure. Okay, great. All the best.
Thank you, sir.
Thanks. Bye.